Well, hello friends. Welcome back to browser hacking. Today we are going to keep working on the parser stuff, and the next step is to integrate it with the browser. So what we're going to do first is we're going to add an option that allows us to start the browser either with the old or new parser, and then once we have a way to run with the new parser, we're going to keep working on making it actually load pages. So I guess the goal I have for today is to make google.com load with the new parser. So let's see if we can get there. Let's see. So we'll start with the option thing. So I guess in the browser app we will have a mode for that. So first thing is we're going to need to parse arguments. We have just been ignoring that. So we'll get an args parser. And I guess maybe we should do that the very first thing we do. We can do it here. Then we need to give it some options. Okay, I don't remember how to use this thing from scratch. I gotta go look it up. Okay. Here we go. So we want to have an option that's called, make it a global actually. We'll call it use new parser, new HTML parser. And will be default false, and then use, this would be browser, use new HTML parser. Yeah, so -n, I guess, and the value name. Well, it doesn't have a value name, it's just a boolean. Okay. So that's pretty good, and then we should be able to get the flag from here, but we also need a positional argument. So that would be our URL that you're specifying that we should load. So this will be the I guess the specified URL. And maybe we call it URL to open. URL required is no. Oh. Okay, there we go. It's quite kind of a mouthful, but yes, I think that's good. And then we can just fetch that instead of looking at like argv1 basically, or whatever we're doing somewhere here. Specified URL. Okay, and then let's just see that this still works. So use new parser. Just I'm going to test this quickly here. So use new parser false. We load welcome page like always. And if I say help, then this happens. That's cool. And what if I say -n google.com? Okay, well there was an attempt, right? Was it just that I said HTTP instead of S? Yes, it was. Okay, so that's great. Now let's go and make it actually use the new parser. So first thing is that where do we do that? We have to do that in an HTML view. So whenever we create an HTML view, we need to tell it which parser to use, basically. So this would just be a temporary hack anyway while we're bringing up a new parser. So this is not like a permanent setting API that we're going to keep. So this is where we instantiate the HTML view. So it's owned by the browser tab. So I think here we'll just do something like set use new parser. Yeah. And then we can just extern that. All right, and then HTML view gets this API, so new parser, ooh, use new parser. Yeah, fix me remove this once the new parser is ready. Yes, Jesus. And for this, when we load a page, where's that? Here, we do a parse HTML document somewhere. This is Markdown, this is Gemini, and this is text HTML. So this is where we actually need to check this flag. So if, oh, this is a static function. Crap. Okay, well, let's make it non-static. So, if m use new parser. Wait, why is it called mm? Oh, that's weird. I guess a little copy-paste mishap there. Okay, so if it's the new parser, then parser HTML document parser. Then we will return. No, wait, how do we do this? HTML document parser. We have the data. And then we need to provide the URL. And that's missing from that API, so we'll include the URL here. Because we need to know what URL we're parsing. That's needed for some relative URL resolution things. So make that non-explicit. All right, that's cool. And then we'll say parser run. Oh wait, that's where you pass the URL. Okay, dang it. So we already had that. I totally forgot. It's been like a day since I worked on this. I already forgot how it works. And then we'll just return parser document. Okay. So I think that should do the trick. Let's see if it actually works. Oh, right, this thing has to be a member function. So we'll make it private. Create document from MIME type. Fancy. So yeah, definitely loaded using the new parser because it looks broken and there was a huge amount of spam. So that's good. And if we just run the browser normally, then it comes up like that. Okay, great. Let's try to open Google just to see where we're at. So we can load the website and then we crash in CSS parse. Okay, so we can deal with these things. And then we have all these JavaScript parse problems, actually. We should probably take care of those at some point as well. It's funny though, because people are working on the JavaScript engine. It's not just me, right? So I got Linus and a bunch of other people regularly working on the JavaScript engine. And I feel like the list of errors here, every time I load Google, I feel like the list shrinks a little bit every day, which is cool. So maybe one day it will be completely gone. We'll see. But anyway, let's see if we can just commit this. So let's say browser or libweb plus browser. Add ability to run browser with a new HTML parser. We can now pass -n to the browser to run it to use the new HTML parser. It's not turned on by default since it's still very immature, but this is a huge step towards bringing it into maturity. Yeah, so that's cool. So what are we going to do now? I guess the first thing we want to do is make the like the basic test page work, because if we can make that work, then we can move on to Google. But first we got to make this page work. And I looked at this briefly at the end of my last 45-hour HTML parser hacking video. So the issue here is that we load the CSS too early. So the way that the new parser works is that when we insert the style element, so actually let me open the web page that we're talking about. It's the welcome page. So when we encounter a style element, what we do is, wait, can I make this bigger? What we do is that we start inserting this text here into the style element, right? And previously, with the old parser, we'll wait until we have the entire text body of the style element before we actually try to parse the CSS. But now, with the new parser, we add one character to it, and then we say, hey, style element, your children have changed. And then style element goes and tries to parse it, and it only has one character at the time when it tries to parse. So this is something that we have to do differently. And I'm thinking that what happens is we send this notification, children changed. We send that to the style element the moment that we add text inside of it. And that worked in the past because then we would accumulate all of the text before inserting it into the style element. But now we actually add the child to the style element immediately when we have one character, and then we keep appending to the text node inside of the style. But we don't send any further notifications. So I'm thinking what we're going to do is we are going to we have to defer or delay the children changed notification until we've actually finished inserting into the style element. So where would that be? That would be in the document parser. So we are in head at this point, and we have a style element. So this is start tag for style. I'm looking for the end tag for style. Maybe there isn't some particular handling. Okay, so what were we doing for the style? We're doing parse generic raw text element, which inserts an element, switches the tokenizer to raw text. Right. Let's bring up the spec. Parsing. Okay, so this would be in style. and this is templates. I think this is in head insertion mode. I wish the spec would have like in head over and over and over on the left and right sides, so you can see which section you're in, because like this is the multi-page version and it's still like super super long, right? Okay, so for start tag style, we go into the generic raw text element parsing algo. So we insert an HTML element, and then we switch to tokenizer state, and then we set up an original insertion mode that we return to once we finish parsing this thing. So how do we know to bust out? The original insertion mode. Any other end tag. Okay. So basically we are handling the insertion mode is text. That's when we're handling text inside of a script, text inside of a style. So I'm thinking when we exit from this mode, we could, at that point, we could inform the parent that we've been inserting into. We can inform him at that point that his children have changed. I think that would work. So I guess, let's see. So the current node is what we're inserting into. Yeah, that makes sense, because the current node is actually always an element. So I almost want to rename this to current element, but this follows the spec language. So yeah, so what I was thinking here is that we would add a behavior that we would notify the current node. Okay, so let's see what this would be like if we did it just for style. So for style, current node, children changed. And then we actually, we don't return here, keep going. Okay, that's progress. But we stopped here, so that's kind of interesting. Your user agent is. Your user agent is. Okay, so what kind of DOM did we end up with here? Let's see. Your user agent is. There's a B. There's some span. And then what comes next? Some small test pages. But these things are just not showing up. That's so weird. I wonder if we have a different DOM than what we had before. We can actually test that now, because we can open this one and then we can compare. Oh, not the JS console. This is the old DOM versus the new DOM on the right. So Serenity browser looking pretty comparable. Oh, here things get different. So yeah, right, so this one has text inside of it because the JavaScript ran. But even if we don't run the script, then what happens later is weird. So these things don't show up in the new rendering. But the DOM looks the same, basically. It ends almost in the same way. We are missing one Whitespace node. Wonder why we're missing a Whitespace node. Let's see if we can figure that out. Let's see what he belongs to. Head element. Alright, so our head element has a little bit less. Or no, it must be the body element. Let's see. Yes, after the body element comes some whitespace in the old parser, and in the new parser there's no whitespace after body. So I think that's just cleanup that the parsing algorithm performs. But it looks to me like this thing should have worked a bit better. So I wonder why we're not seeing more text. Line box borders. Okay, we're gonna have to look at the layout tree here. All right, so what is going on? Your user agent is blah, blah, blah. Wait, there's no text inside of these things. No line boxes. Why is... Why is that? It's so strange. Because if we... this li here has an anchor tag in it, and then the anchor tag has text inside of it. So we have a layout list item with a layout inline inside of it with a layout text inside of it. And this text here should contribute lines to the containing block, which is layout list item. But he doesn't have any lines. I wonder if that is because we... No, if we do a relayout, then it should figure out that there's text. We're confused about the text content somehow. But it was there in the DOM. Or what? Okay, we're gonna figure this out. Maybe we should reduce the spam a little bit. serenityos.org. Yeah, we're parsing the whole thing. That part's fine. Let me just quickly look at those DOM nodes again. So yeah, we have text inside of these. So we should be able to do this. It's kind of interesting because the new parsing algorithm, it should really only affect the way the DOM is constructed, but obviously it's going to have some side effects because of the way we were doing insertion differently before. Let's see, who else cares about children changed, I wonder? And what does layout text have? Well, we want to look at the text inside of a layout text, and we go to the text node. So the layout text doesn't, the layout object that corresponds to a text node does not store his own copy of the text, right? So when we're doing layout and rendering, then we're always looking into the DOM to fetch the text from there. I said confidently, and then I noticed text for rendering right here. So let me see what that is, because apparently I forgot that that existed. So text for rendering is, oh, I guess it's if we do text transform, then we uppercase or lowercase and things like that, and then we store that in text for rendering. Is that right? No, we transform before painting. Okay, so we don't store it. Textile rendering is Whitespace collapsed. Okay. So it's after we have figured out what to do with the whitespace. Like, should we wrap? Like, if we decide to break a line somewhere, then you might have a line break between two words that are separated by space, right? And that space that's in between those words, you don't really want it on the right of your last word on the line, especially not if you're right aligned, because then it would like shift out the content to the left, and you don't really want it to follow you to the next part of the line either. So you have to get rid of it. So we modify the text a little bit by collapsing whitespace into single spaces, right? There's probably smarter ways we can do that. I'm just talking out loud here while I'm catching up with how this whole thing works. But this behavior change is suspicious as heck. So I guess step one is we want to get the JavaScript running anyway. So that was a script source, right? So we want to, previously what we would do is we would just fire off a load, and then when the load finishes, I can show you in the script element implementation. So when we are inserted into a document, we look if we have a source attribute. If we do, we go and fire off a load for the script, and then we parse and run it once we have the data. And we actually load synchronously. So that's how it has to work, right? Because when the script is loaded like this, you can't continue parsing the document until you actually run the script. So what are we gonna do? I guess we need to execute the script. So I wonder if we are reaching this part here that does prepare script. I would expect us to be here. So let's check if we're here. Let's assert not reached, just to test. To see if this is where we are. Oh, forgot about dash n. Okay, yes, that's where we are. 216, so we have a source attribute, we are inserted by the parser, and we don't have async. So I feel like we have to go back into the script element spec. So what was this thing? When the script is ready, tell him that the parser should execute him. Okay, and then I guess when the script is ready, no, pending parsing blocking script, right. So what is this thing? An end tag whose name is script. We're not here because this isn't inline script. We had inline style but not inline script. Okay. And this is just a text insertion. And this is also the same. Wait, I can't tell what modes I'm looking at. Where am I supposed to run these scripts? Only here? Oh. Okay. So is this where the script execution is defined? Okay, so to prepare a script, that's something that we were doing. It's this function right here, actually. It's prepare script. So we are in prepare script. And geez, what step was this? If we have source, parser inserted, but no async. Where are we? It's classic. Here we are. We're at script type classic, source attribute, parser inserted, no async. This element is the pending parsing blocking script. When the script is ready, set the elements ready to be parser executed. Okay, that's the flag that we're interested in. So we're setting that here, ready to be parser executed. But when is the parser supposed to execute this? Let's see what it says about that here. Oh, that's where we were. Hello. Am I in the right place? Okay. Text insertion mode, the end. The parser will handle executing the script. But when? Ready, parsing, parser executed. Take me to the parsing page. Parser executed. The end. Once the user agent stops parsing the document, we must run the following steps. Wait, are we allowed to continue parsing past one of those? Dude, I'm so confused right now. Maybe I have this wrong. Let me test that real quick. Script, document, right. Hello. Or no, I want to do an external script. Script, if I do that, hello, friends, like this. Look at this beautiful HTML. And then we have X.js, and here I put document right. Ooh. Now what will happen if I open parser? Hello, boo friends. Okay, so it does load this thing, and it does not continue parsing. But if I put async on it, then it doesn't happen at all. Okay. Fine. Yeah, so we have to stop what we're doing and run that script. So the list of scripts. I feel like there needs to be an end tag whose tag name is script. But I'm not in the text insertion mode. Or should I be? Start tag whose name script. Alright, so we are in head, right. We get a start tag whose name is script. And then we always switch to text. Oh, wait, maybe we're skipping that. Handle in head. So if we have a start tag named script, then by golly, we always switch to insertion mode text. So we'll always be in text. I just thought that we were not in text because we didn't have any text in between the start and end script tag. So I have been flailing up and down here for a moment, but I guess now I know what I was doing wrong. So we are in the text insertion mode, just that we don't have any text. So we end up here, and we've prepared the script. So are we doing all of these steps? Handle text, parser pause flag, prepare the script, nesting level, blah, blah, blah. Let the insertion point have the value. Oh, then we're here. At this stage, if there is a pending parsing blocking script, we just set that one. Oh, so it says right here what we should do. Finally, after I've been so blind. Text insertion mode. Let me just bring that back. Okay, so now I've been running around the code for 20 minutes, I feel like. But now I know what to do. I just have to continue implementing the text insertion mode for the script end tag. So here, if the document has a pending, no, not set pending, pending parsing blocking script, we need a getter for that. So like that, return m pending parsing blocking script. So, can't see what I'm doing underneath here. All right, so now we have a getter. So if we have one of those guys, then what should we do? We should check if the script nesting level is not 0. Set the parser pause flag to true, and abort the processing of any nested invocations of the tokenizer. Yield and control back to the caller. Yeah, this stuff is going to get tricky, and we don't have to deal with that right very now. So I'll just put a fix me, and then we'll say to do here so that we crash. Because we're not going to run nested script right now, and we can leave that for the future. Okay, because yeah, the tree construction stage of this particular parser is being called reentrantly. That is a peculiar situation with document write. But we are not in that situation. We are here, so we're in the else branch, you could say. Let the script be the pending parsing blocking script. There is no longer a pending parsing blocking script. Okay, so then we'll do non-null header to script element. We'll take ownership of the script at this point. Pending parsing blocking script, and then we will do set pending parsing blocking script null header. Pass a batch there. Okay. No? Oh, I can't do that. Oh, interesting. I thought I was the one who was calling that, but I guess it was the script element who was doing this. Then we can do something like non-null ref header. Let's do the most expressive possible thing here. So that would be take pending parsing blocking script, and we'll move it. Or no, we'll do a release non-null. Yeah, because now we can write our code in a rather expressive way, I think. We'll do auto script is document take pending parsing blocking script. Although we should probably say that only the parser is allowed to do this. So there we go. Okay, so now that we have this script and we are supposed to run it, I guess. So block the tokenizer for this instance of the HTML parser, such that the event loop will not run tasks that will invoke the tokenizer. So I don't know exactly how to express that. I guess we can just tell our tokenizer set blocked true, but I don't know yet exactly how that's going to work. So we'll just say that he's not blocked by default, but we'll have a set blocked API and an is blocked API. But I don't exactly know how we're going to handle that. What's wrong with this? No member. Wait, where was I putting this? Oh, I'm putting it in the parser. Okay, I'm stupid. Tokenizer. This goes here together with my mblock file. Yeah, the whole blocking the parser, blocking the tokenizer type stuff, it's going to be interesting to figure out how all that works. But we can do it. So where are we now? We are here. Let the script be, oh, it's called the script. Should we follow their naming? The script. Block the tokenizer. Okay, so we blocked it. And then if the document has a style sheet that is blocking scripts, or the script's ready to be parser executed flag is not set, spin the event loop until the parser's document has no style sheet that is blocking scripts. Okay, so I think we'll assert that the script is ready to be parser executed. We don't have a good abstraction for spinning the event loop like that with like a condition, although we could make a nested event loop and we could make some kind of callback that will exit out of the nested event loop at the right time. But it's going to be a big fat fix me for that, I think. What is the style sheet that's blocking scripts? I don't remember these things. Style sheet that is blocking scripts. If its script blocking style sheet counter is greater than 0. So who uses this? The link headers. Interactions of styling and scripting. I guess it's that if you want to access the content of your style sheets programmatically through the CSS object model, then it would be irritating if it would be timing based, right? But wait, it's not defined. Yeah, I'm not exactly sure. I feel like okay, this is kind of advanced stuff. Like how should we behave with regards to unfinished style sheet loads? So let's not worry about that right now. That'll just make everything confused. So back to this thing instead. So we can definitely add this thing that checks ready to be parser executed because we have that here in a flag. So bool is ready to be parser executed. Okay. So we assert that, and then here we should say fix me spin the event loop. Let's copy this whole thing out. Dun, dun, dun. Okay, so that's pretty nice. Let's maybe tidy up this comment here too, since we were tidying up the comments. Doing a little bit of manual line breaking. Okay. If this parser has been aborted in the meantime, return. So we'll put a big fat fix me here too, I think, because I'm not sure how we will implement parser abort. This could happen if, for example, while the spin event loop algo is running, the browsing context gets closed, or the document open method gets invoked on the document. Right, so if you, I guess, close the window or something, close the tab, when we return from the nested event loop, then we just want to bail. So I guess we can check. So if m aborted, return. That's pretty straightforward, and then we'll have to have a way to set that state, but aborted false. Yeah. Okay, unblock the tokenizer. Set block false, such that tasks that invoke the tokenizer can again be run. Cool. Let the insertion point be just before the next input character. That's the tokenizer insertion point, so I'm just gonna have this fix me, handle the tokenizer insertion point stuff. And then increment the parser's script nesting level by 1. It should be 0 before this step. Okay, so we'll assert that the script nesting level is 0, because that's what it should be, according to Dr. HTML. And then set the parser pause flag to false. And wait, I'm skipping over something here. Over here. Oh, damn it. Increment. Yes, right, so this came after decrement. And if it's, yeah, so it should always be 0 after that, so we'll assert that again here. And then here we should execute the script. Dang it. So the script, execute script. That's cool. So then we'll just need to be able to call that from the outside, so we'll do that. Oh, dude. And then more insertion point stuff. I'll put that here. If there is once again a pending parsing blocking script, then repeat these steps from step 1. So we go here. So this we can actually wrap in a while there is a pending parsing blocking script. Okay. Let's see if we can make this work. Document.h. I was looking into, oh, the HTML script element, right? So let's put this out of line. That's fine. Document. This is not the right document. Here we are. I like this name take, like when you're taking something from somebody, so he like gives up his pointer. I find that naming very pleasant. So like here we're taking the pending parsing blocking script from the document, so it returns a non-null ref butter, which is perfect for us because that communicates that it's guaranteed to be, we're holding a reference to it, guaranteed to not have to deal with null. All very nice things. Let's just close that. Alright, so that's the old parser. New parser, crash. All right. The script is not ready to be parser executed. Oh, right, because we're doing an asynchronous load, so it's not going to be ready right away. Ready to be parser executed. So we're here, and then we say when the script is ready. Presumably we have fired off a load for it. Let's verify that we're doing that actually. So here, I guess for now we can do a load sync, because then we will have the script always fix me. This load should be made asynchronous, and the parser should spin an event loop, etc. But for now we can do the loading synchronously. Okay, so now what? It's still not ready to be parser executed. Well, are we actually doing this, I wonder? Debug, load sync, script, load sync. Let's put some really colorful text here. So, how about some red? And then we'll put the URL, just so we can catch what we're doing. Okay, so we're loading this thing synchronously. Welcome.js, which means that this thing here will happen right away. So script became ready will be called. But we don't have a callback for it. Right. And then later on, we are here, and we say set pending parsing blocking script. That's fine. And then we say when the script is ready, set our ready to be parser executed flag to true. Wait, script became ready. We're never updating mscript ready, are we? No, we're not. Okay, so we should always set script mscript ready, and script became ready. Otherwise, this when the script is ready is not going to do anything. Okay. And we loaded. Don't know if we did much, but we loaded. Oops. Why is this in a B tag? Is that accurate? That doesn't seem correct. Is that what the problem is? I gotta go and dig into this here. H1 P. Something here is not going right. We don't have that B tag over in the old DOM. Let me open up this guy in Firefox. Maybe he'll tell us. What's actually happening. So can we get a inspect element? Thank you. And why is this so weird? Okay. The B tag is inside your user agent is. Yeah. Wait, so how did that look in the markup? we have a B with a span with a B. And are we just like totally messing up the parse of that, maybe? Is that what's going wrong here? I guess we can actually scroll up through all of these individual parsing steps. So here is the first link, some links, blah, blah, blah. Here's that B tag. Okay, so we have a start tag. We're in body, and we have a start tag B. And then we're in body, we have a start tag span, an end tag span, end tag B, end tag P. So from the parser input side, it looks good. But I feel like we're not correctly, this thing is not correctly closed. So in body end tag B does not appear to do the right thing. Handle in body. So this should be like that. So here's start tag for B. And do we have an end tag for B? Maybe we're not handling end tag for B correctly. Like we're supposed to do it somehow, and then we're just doing a fallback instead. Let's have a look at that. In body. Okay, so these are start tag B right here, and then here's end tag B. Run the adoption agency algorithm for the token. Huh. The adoption agency algorithm. It's a modest 21 steps. All right. Cool. Let's do it. So I guess this is why we're not doing the right thing. So let's see, where was this? This was here. So if token is end tag and token tag name is one of these, by the way, I added this is one of. It's just a little templated helper in the string class. So you can say like is one of, and then you can have an arbitrary list of things that could be one of. I find that it's really nicely expressive. I feel like I'm saying expressive over and over, but it's important. Okay, so now we have to run the frickin' adoption agency algorithm for the token. So I guess we will just say run the frickin' adoption agency algorithm token, and let's not curse. All right, so adoption agency. This is mentioned in a whole bunch of places. What is this even? Misnested tags. Is that what this is? I guess in our case, the tags are not, I think they're not misnested, are they? So maybe we'll just go on an algorithm fast path. B span span B, right? I don't see the problem here. Maybe I'm missing something, but anyway, we'll just we'll do the adoption agency, see what happens. Adoption agency algorithm. Well, HTML token. Okay. It takes as its only argument a token for which the algorithm is being run. Step 1. Let subject be the token's tag name. Step 2. If the current node is an HTML element whose tag name is subject, so if current node dot tag name is subject, and if the current node is not in the list of active formatting elements, wait, if the current is not in the list of, let's see. Do we have some nice way of checking that, I wonder? I feel like I'm going to have to loop across this thing. But maybe I don't. But maybe this is where we'll bail, actually, because we have an early return here. So let's see. Not in the list of active formatting elements. I feel like maybe we should make this thing a separate class. Okay, so let's see. Let's copy the pros, or the step name here. Step description, so that we can have it with us. Okay, so for auto element in M list of active formatting elements, if element is the same as current node, let's see, in list of active formatting elements is true, right? So if it's not in the list, so if not in the list, then a stack of open elements, pop, return. Let's see if that's all that we need here. Or this should be a to-do, actually. Maybe it's not that simple. 550. We got some more adoption to do. All right. But this is so weird to me because I feel like we shouldn't have to do anything special here. So because the tags are correctly matched. Start end, BB. Why is it this way? Am I misreading this? If the current node is an HTML element whose tag name is subject. So the current node at this point will be a B, because the current node is the bottommost node on the stack of open elements. So that's B. And the current node is not in the list of active formatting elements. But that's the thing, it is on the list of active formatting elements. But were we not supposed to put it there? So in body, when we encounter a b tag, we put it on the list of active formatting elements. So where's the fricky fracky b tag? Come on, b. Did I miss it? Where are you? Okay, start tag whose tag name is one of B first, please. Yes, thank you. B. Okay, insert an HTML element. Sure. Push onto the list of active formatting elements. What does that mean? So here we're just doing a called append. But maybe this is more intricate than I thought it was. When the steps below require you to push onto the list of active formatting elements, then we must perform the following steps. If there are already 3 elements in the list, after the last marker, if any, or anywhere in the list if there are no markers that have the same tag name, namespace, and attributes as element, then remove the earliest such element from the list. For these purposes, the attributes must be compared as they were when the elements were created by the parser. Right. And then you add it to the list. So in our case, it's the only thing on the list. So we add it to the list, so it'll be on the list. This adoption thing is weirding me out. So what were we doing previously as the fallback? I mean, okay, fine, whatever. We just have to deal with this adoption agency. I don't know why. This somehow feels like we're going down the wrong path, but maybe this is the right path, and I just don't get it. Let's just do what the Dr. HTML says. So, outer loop counter should be 0. I can do that. Outer loop counter 0. Okay, here's the outer loop. We're gonna go to, boys. If outer loop counter is greater than or equal to 8, then return. Okay. Increment outer loop counter by 1. Yes, sir. Let the formatting element be the last element in the list of active formatting elements. That condition is between the end of the list and the last marker in the list. We don't have markers. I feel like we're gonna, okay, let's put this in a separate class because it keeps feeling so weird to have a vector, and then I keep saying, oh, we don't have markers, and we should probably just put it something. So we'll call it we'll copy the stack of open elements, and we'll call this the list of active formatting elements. Yes. List of active formatting elements. Okay, let's figure out what this thing is here. So it's the, well, thing that we just named it, the list of active formatting elements. And it needs to be able to have elements, but they also need to be markers in here. So we'll have something like struct entry with a ref putter to element. We'll call it the element, and if it's a null element, then it's a marker. How about that? And then we'll just have a regular vector entry and entries. All right. So what kind of API do we need here? I know we've had add as an API, so add the element. That'll be something like this. Maybe we'll put this out of line. List of active formatting elements. Oops. And then what we'll do is we'll just say entries, append a new entry with element. All right, and then we can have a list of active formatting elements, add marker, m entries append, like that. Marker. Okay. No, it's ambiguous. All right, my bad. Fine. And then I guess we also want. I already forgot how it was being used. Document parser. Here we'll say list of active formatting elements. Or you know what? We should commit some stuff. Actually, I'm being a bit lazy with that. What do we have in document? Just adding a way to take the pending parsing blocking script. That's good. And then there's the load sync. Let's not log that quite so violently. And then we'll see what we need from here. So this is the adoption agency. Let's not do that. This is more of that stuff. That stuff is basically good. Okay. So the style part I didn't like. That was kind of hackish. This part right here. So let's actually do this. Okay, and then we can put it back and commit at this point. Bring up basic external script, non-async external script execution, or new parser. Yeah. This only works in some narrow cases, but should be enough for our own welcome.html at least. Should be in theory, I say, even though it's not working yet. And oh, I forgot about the blocked things. They belong to the same commit, so let's make sure that we have those. Okay, and then the list of active formatting elements. Or here, we'll replace this guy with a list of active formatting elements. Okay. Because with things like this, it's like they have all these little behaviors that it's much nicer to just go and segregate them into a class instead of implementing these behaviors at various points in the parser, right? So here, for example, we wanted to check if the current node is in the list of active formatting elements. So instead of iterating it here ourselves, we should be able to just say if the tag name is subject and the list of active formatting elements contains, does not contain current node, then do the business. So tag. That's a lot better. Okay, so then we need to have a contains API. Contains element can be const actually. Right, and then we'll just sketch out one of those guys real quick. So contains entry of my entries. If entry element is element, then my friend, return true. Otherwise, Cool. So then we have all these other goofy APIs, like this algorithm here, which basically iterates the thing using a bunch of vector stuff. So for this particular thing, I guess one thing we could do is, this thing needs to care about markers. Yeah, I think markers become relevant when we do stuff like applet elements and whatever else cared about markers, but it's a good thing that we're adding it. So let's go ahead and, just for simplicity right now, let's expose the vector entries, because then that algorithm can operate on the entries. We don't have to convert so aggressively here. I would just say entries.last, and so on. And we can make a const version, a non-const version rather. No viable thing, last dot element. We'll insert here just to be sure. Element. Oh, this code is a little awkward, but it's okay. At index.element is new element. Okay. So wait, what's down here? Oh, append was add. That's fine. So list of active formatting elements. The last element in the list that matches something. Between the end of the list and the last marker, if any, or the start of the list otherwise, and has the tag name subject. So basically, you want to start from the back of the list and find the, iterating backwards, you want to find the first element in the active formatting element list that has a given tag name. And if you encounter a marker, you gotta stop. So last element with tag name before marker, let's say. And the tag name is going to be the subject. Okay, and then we can go and actually put this into this class right here. Element. By string tag name. Okay. And how do we implement this? We have SITI is the entry's size. Okay, and then entry is an entry's I. If entry. So if it's a marker, which I suppose we could find a nicer way to express, bool is marker, like that. So if entry is marker, then return a null putter, right? If there is no such element, then return. And instead act as described in the any other end tag entry above. What any other end tag entry above? Alright, well, hold on. We'll figure this out. Wait, is this thing run in more places? No, it's only one place. Okay, so I guess it refers to the any other end tag in the in-body insertion mode. So last element with tag name. So if it's a marker, bail. If the entry element tag name is the tag name, return entry.element. Okay. That's fine. If formatting element, here this is a to-do, and then what were we supposed to do? If there's no such element, yeah, dude. If this is where we end up, like I can barely follow what we're doing. I'm just transcribing. If this is where we end up, then maybe that's not so bad. Outer loop. Oh shit, I defined it without doing something with it. Oh. I'm sure we'll find a use for that. So where are we now? Last element with tag name before marker. How did we manage to crash? We went too far. Assertion failed. I is less than M size. I should probably have started from size -1. That was a silly mistake. Backwards iteration is slightly harder than forwards iteration, let's be fair. But I like it. Now we're at 560. So we're here. We still have more frickin' adoption to do. If formatting element is not in the stack of open elements, so if stack of open elements contains formatting element, if it does not contain it, then this is a parse error. Remove the element from the list and return. So we should remove the formatting element. Formatting element is the last element that matches this. Okay. Oh, wait, hold on. What is that type even? So we should remove it from the list. Let's put it to do here, because removing it from the list is a little bit awkward. And let's see if we end up here. So fix me. Okay. If it is in the stack of open elements, but the element is not in the scope, then this is a parse error, return. Okay, so if stack of open elements contains, I mean, we know that it contains it now because we didn't take this branch, but the element is not in scope. So if mStack of open elements is, or has in scope, and then we need to say formatting element, then it's parse error return. If formatting element is not the current node, this is a parse error, but do not return. All right. Let the furthest block be the topmost node in the stack of open elements that is lower in the stack than formatting element. Oh man, this is starting to sound weird again. So let's see if we get this far. We got to implement this has in scope with an element reference. So we only have has in scope for tag names. So let's see, we have to do the same thing for elements. Wait, the element is not in scope. But it has that element in specific scope. Wait, this is, no, this is confusing. Hold on. Target node. If the node is the target node, yeah, so we gotta compare against the target node here. Okay, so just adding some more APIs. It's probably a way to share code there. This whole business with like element in scope is a little bit confusing to me, to be honest. But we'll just try to make a faithful implementation. All right, 575. We're still going in the frickin' adoption, frickin' agency, frickin' algorithm. All right. So formatting element is not the current node. This is a parse error. All right, so we are at step 10 out of 21. So let furthest block be the topmost node in the stack of open elements that is lower in the stack than formatting element and is an element of the special category. Furthest block Oh man, how are we gonna compute this? The topmost node that's lower. So the stack grows downwards, right? So it's the earliest on the stack that is sooner than formatting element. So before formatting element on the stack, and is special. What was special again? It's one of these jerks. I feel like we only have B on the stack here, so maybe we can skip over this one and be lazy. We'll do a fix me here, and we'll pretend that we didn't find it for this block. So let's say ref footer element for this block. We'll just write it out in null footer like this, pretending like we didn't find it. If there isn't one, then we must first pop all the nodes from the bottom of the stack of open elements from the current node up to and including formatting element. Then remove formatting element. Okay, so this is actually where we want to go. This feels like us. So we don't have a special block surrounding us. So we have to pop until we reach formatting element and then pop him too. So while current node is not formatting element, stack of open elements pop. And then we reached formatting element, so we pop him too. Pop once more. And then remove it from the list of active formatting elements. Remove formatting element. It's a little bit iffy to me, this part, but I guess it's just a matter of like, and then return, yeah. I guess it's just a matter of iterating until we find it. So remove with a given element. Remove with a given element. We'll just iterate until we find it and then nuke it. Oh, in fact, maybe we can even use a little vector trick. Entries, remove first matching. Look at this. Return entry dot element equal to element. Look at that shit. It just worked. Oh man, that was freaking tedious, and we didn't even do the whole thing. But I think that's enough adoption agency algorithm for one day. I don't particularly feel the need to finish it, but we'll say fix me. Implement the rest of the adoption agency algorithm. Oh man. Okay, so now that we actually parse correctly, we get the right thing, but we still don't have our script output here, so that's a little bit sad. What happened to that? Well, first thing we'll do is we're gonna commit this. We'll add those. Yes. Let's let's see, should we do a commit with only adding this new class? I think that would be good. So no adoption agency. Well, whatever. Actually, let's do them in one commit. It's not the end of the world. Look what. Implement the first half of the adoption agency algorithm. The AAA is a somewhat daunting, I must say, somewhat daunting thing you have to do for certain elements, certain and tags, certain tags when inserted inside the body. Somewhat daunting algorithm you have to run. I don't know why it felt daunting to me, but I'm commenting. The purpose of the algo, the purpose of it is to resolve issues with mismatched tags. This patch implements the first half of the AA, and we also move the list of active formatting elements to its own class, since it kept accumulating little behaviors. Markers entries are now signified by no element pointers on the list, in the list. Okay, so that's cool. Now, let's investigate why that script did not execute, or at least didn't seem to execute. Execute script. See if we actually get here. Debug. Executing script. Maybe we can even show you the source that we're about to run. Script source. Let's put some flashy color. So much to look through. Maybe we should allow you to run the parser without noise. Okay, so look at this. Executing script. Add event listener. So DOM content loaded, then we're gonna do this script business. But it does not appear to have worked, does it? So we're setting the inner HTML of the UA. It would be cool if you could see like exceptions that were thrown while the page was loading. Would be cool if they showed up on the JS console. So let's see if we can talk to the engine. Document get element by id UA. Okay, let's try to set something. Navigator user agent. Okay, so that totally works. So I guess we're just... Are we running the script at a bad time? So we're definitely running it. This old way of running it will go away later. Okay, so we're running the script, and then set inner HTML. Let's see what it says. Or wait, what was the script actually doing? I mean, it adds an event listener. Maybe this part goes wrong. We could mess with the script, do something much simpler in there, see if it actually runs. Like alert, hello, right? Okay, all right. So we actually do run the script. Interesting. Oh, we're not sending out DOM content loaded. That's why. Because DOM content loaded is produced by the old parser when we finish parsing. So we can just dispatch a DOM content loaded in the new parser. I wonder if it says something about that here. DOM content loaded. Oops, that's actually something you should do. The end, right? So when we've finished parsing, there's a whole bunch of things that we should do. I think we can short circuit this list a little bit for convenience right now. So basically, run the parser, and then when we exit, this is the end, right? So we should do a whole bunch of things. The end. Should run scripts and stuff. Anyway, we will just fire the event. So document and then service worker something something. I don't think we give too much of a crap about service workers right now. We have quite some time before we have to start worrying about what to do about that type of stuff. I'm not even a huge fan of service workers, to be honest, but it's a bit silly to complain about problems that are so far ahead. Okay, so that did not appear to fire the event in any meaningful way. So let's remove the hello, DOM content loaded. Am I messing this up? How am I messing it up if I am messing it up? Dispatch the event. I guess here we can say if definitional debug. Or we'll say parser debug. Okay, so we loaded, but did we do the event? Dispatch event. I guess we can say here, dispatching event name on tag name. This, I don't know, just something so we can see what we're looking at here. I feel like I don't see a DOM content loaded. I see a whole bunch of mouse moves. Very, very noisy. But there's no DOM content loaded. Why is that? Dispatch event. Wait. We're returning, that's why. We should break. So that we actually run the end. That's why it's not doing that. Awesome. Okay, now let's try Google. Come on now. Oh, so close. Okay, so now it's a CSS parser. chokes because we try to parse a single character CSS. Okay, so we can deal with that, but let's just let's do some commits. So check out the script element change and the node change, and we'll make the parser debug thing be a default on for now because this is gonna take some debugging. Libweb. Fire a DOM content loaded event at the end of, or when the new parser is finished. With this change, we can finally load and render welcome HTML. That's awesome. But it would be cool if we could get Google too, because that's what I said I wanted to achieve. So let's see. So we won't have to deal with that style element. So they have style element with inline style, and that would be in head. Oh no, wait, it's handled text. We're in the text insertion mode and we reach the end of a style tag. So this is the hack that I added. The problem is that Google, we are reacting to the children changed, which comes when it's inserted also. So let me show you the call stack. So we see style element children changed because we are doing insert character in the document parser. And this is the very first character, so the thing is completely empty. So maybe what we should do here is suppress the delivery of children changed. And just make sure that we always do it at the end of a handle text situation. Maybe? I'm not sure. Maybe we'll do a special one for style for now. So this would be hackish. Fix me. This is a bit hackish. Can simplify this once we don't need to support the old parser anymore. Since then, we don't need to maintain its children changed semantics. Okay, and then when we do insert character, so this is where we insert a text into the parent for the first time. I guess one thing we could this could be a total hack actually. We could insert the text with an empty string instead of inserting it with the very first character. So we could just do an empty string, and then we could change the text afterwards. So we would just put this somewhere. So auto new text node, and then we would do text node set data builder to string. Okay, so this will cause it to not, it will fire children changed, and at the point when we fire it, the content of the text node inside the style will be empty. And because of that, the CSS parser is not going to choke, and then we'll actually send children changed later on, which will make everything snap into place, hopefully. So let's see if this works. Should have turned off the debugging. Alright, I should really have turned it off. Okay, that's taking too long. Let's try again. Tokenizer. Okay, all right. We have an unimplemented tokenizer thingy. After attribute value quoted. I'm sure that we can implement that. Tokenizer. After attribute value quoted. What are we supposed to do here? So we're getting an H after attribute value quoted. This is a missing white space between attributes parse error. All right. Well, maybe Google has a parser. We could actually verify that they have that, just to be sure. So let's run with the old parser. Go to Google. Get the source. We'll put that here. HTML. Oh, dang it. I wanted to edit it. We need to do some more work on the desktop. Okay, so here we have that, and then what was I looking for? I guess this weird string here, t:8. So there's that. :8 paren semicolon, and then wait, a on click. They're putting a piece of JavaScript code in an unquoted attribute. Savages. All right, so we get to the end of the thing. Named character. Wait. Why does it think we're in named character reference? What the actual? So, oh, we started parsing a character reference at some point. Tab. I guess here. Oh, shit. Our character reference parsing is not strong enough. How about we... I don't want to sit and implement all these named character things right now. So what if we would just ignore not going to character reference when we encounter it? And just see if that works. Nope. Where are we now? Still went into named character reference. Okay, so I guess there are many places where we jump into character reference. Attribute double coded, for example. But what if we just skip over all of those jumps? I'm just hacking it now to see what else comes up. Basically, character references are like these things that start with and, so like and amp and copy, these type of things. And we have to go and make a string table out of all of these things, and then they should map to the corresponding Unicode code point. But I didn't set all that up. So we don't know if we're supposed to bail out of that mode. So let's see. Okay, so now why do we die? Parser 869. 869. Some table tag business. Okay, well, I guess we can deal with that. In table, or do I really want to deal with this? It feels like a whole bunch of stuff to do here. But maybe it's not that difficult. In table. What do we do in to h to er? Clear the stack back to a table context. It means that the UA must, while the current node is not a table, template, or HTML, pop elements from the stack of open elements. Okay, we can do that. Clear the stack back to a table context. Which while current node is one of, oh wait, hold on, while not current node tag name is one of table template HTML, we should pop. Okay, nice and easy peasy. So we'll just put that here. All right, now we're doing that. Okay, so to h to er. Then what we should do is insert an HTML element for a T body. We have to make a fake T body start tag token. We have a fake token somewhere else. Yes, let me just copy this fake business. So fake T body. We should probably put this into a helper function. T body insert HTML element fake T body token, and then switch the insertion mode to in table body. Return. Reprocess the current token. Okay. So we process using the rules for insertion mode in table. Wait, it doesn't process it using these rules. It says reprocess the current token. But I feel like reprocess means I should process it in the new mode. So we'll say it that way. Okay. So in table, how hard can it be, right? Table body. Okay. Seems doable. So I guess we'll see what breaks here. I guess I was hoping that this would be that there wouldn't be too much new stuff to do on Google, but it might be that it gets really intricate. I don't want to start accumulating too many hacks here, so we'll see. Man, this thing is just really long, isn't it? Maybe we can save a copy. Okay, so we died on 8:54, so now we're here. we can at least see why we died. So we got in table start tag v-align top, and then we are in table body with the same tag tr right. So it's just a matter of doing a clear the stack back to table context. Is start tag, and token tag name is tr. For the token, and then switch the insertion mode to in row. Return. Cool. And let's see, so we downloaded it, then we could actually check it out here. Wait, what's even in this thing? This looks weird. Wait, why can't I Control C in the shell? I'm used to Control C just creating a new line. It doesn't do anything. That's weird. Anyways, so that thing is so noisy. Like, how are we gonna get through this with all that noise? I guess we can check if insertion mode is not. And what was the extremely noisy mode? In body. Or actually, let's check if the token is character, then ignore. Okay, so now we're in row. We have a TD. In row. And token tag name is one of th or td. Clear the stack back to a table context. Insert an HTML element for the token. Switch the insertion mode to incel, the famous incel, and then insert a marker at the end of the list of active formatting elements. Ooh, it's happening. We're actually going to call add marker. Cool. All right, and now we're in the famous incel mode, so I guess we gotta see what's going on in there a little bit. Token. Oof. So what is happening in here? Various things, right? So let's sketch out the things that we have to deal with. So token is end tag, and token tag name is one of td or th. Okay, to do. Or if token is a start tag, tag name is one of, And then here, I like that we can just copy this now. Click. Okay. Tag name is one of these guys. Then it's a straight up parse error, ignore the token. All right, got it. And then if token is end tag and token tag name is one of these guys, to do anything else, process using the rules for insertion mode in body. Token. Okay, let's see if we hit any to-dos. Probably gonna hit some to-dos. Alright, so we hit one in row, start tag TD, line 129. Oh shit, forgot to add it to this list. In cell. What a terrible name for an insertion mode. Insertion mode incel. Alright, anyway, I gotta stop giggling at that. So, now what? Reconstruct the active formatting elements. Ooh, we have a marker now, and it's messing crap up. This needs to care about markers, because we just inserted one. Dang. Okay, so if there are no entries, there's nothing to do. If the last element is a marker, or if it's an element that is in the stack of open elements, then there's nothing to reconstruct. Okay, so we should bail if the last element is a marker. Entries, last is marker, return. There's more stuff we need to do with markers here, but at least this might actually be enough for now. All right, now we're on 878 in the cell and tag TD. Okay, we can deal with that. So we're actually closing the TD. If stack of open elements has in table scope HTML. Oh wait, no, hold on. With the same name as the token. So token tag name. This one always trips me up, and I think it's like an HTML element, like an HTML tag. Then this is a parse error. If it does not have that, ignore. Got it. Otherwise, generate implied end tags. Now, if the current node is not the same as the token, so if current node tag name is not token tag name, parse error, sure. And then we pop until we find somebody with token tag name. So while current node tag name is not token tag name, stack of open elements pop, and then we pop once more to take one off with that tag name. Clear the list of active formatting elements up to the last marker and then switch to in row. Okay, so what does it mean to clear the list? Okay, so list of formatting elements, clear up to the last marker. Let entry be the last one. And then we remove it. And if it was a marker, we stop. Okay, so while entries is not empty, entry is last. Make a copy like that, okay. And then entries take, we can do take last actually. Take last. If entry is marker, return, break. Cool. And then what? Okay, now we are in row and we have an end tag tr. Okay, so in row, and we did the first one only, and then we have if token is end tag and token tag name is tr. Then if stack of open elements has in table scope tr, parse error, ignore token. Otherwise, clear the stack back to a table row context. Oh shit, we were supposed to do that here as well. I need to be a bit more wary with those. It seems like there's more than just one type of table-related context. Table row context. So what does that mean? It just means that you gotta keep popping until, well, it's not a TR template or HTML. Okay. So clear the stack back to a table row context. Okay. That's good that we noticed that. Table context. Back to a table. Do we have more of those? Table body context. Okay, so there are a few. Table row context, table context. Okay, so those are the three ones. And presumably this one goes to t-body. Or t-body, t-foot, t-hat, okay. So t-body, t-foot, and t-head. Cool. In table body. Then here we actually have to go and do the table body context. Great. So we were dealing with in row, and we got an end tag tr. Pop the current node, so stack of open elements pop. And then switch the insertion mode to in table body. Sure. And we have a bunch of other things which we can probably avoid dealing with. I feel like we need to handle some end tag in the body state as well. But I'm just going to be lazy and figure out which one it is this way. So 944 in table body. we have an end tag table. In body, in table body. An end tag whose name is here. Cool. So it's interesting that these two are handled the same way, so a start tag or a table end tag, but I guess we'll do what he says. If it's a if it's a start tag and token tag name is one of all of these rascals. So if it's this, or if it's a table end tag. Oopsie doopsie. And we'll parenthesize and parenthesize a little bit more. There we go. So if we don't have one of these guys in table scope, okay, I'll make that a fix me. Otherwise, clear stack back to a table body context. Pop the current node. Set the insertion mode to in table. Reprocess the token. Then we'll be doing the end tag in the in table mode. So we'll have an end tag for table. Where are you? Did I already do this mode at some other point? I feel like I didn't write this out now. Maybe I filled it in the other day. Alright, 10:14. Reset the insertion mode appropriately. What the X? In table body, end tag table. Sure. Reset the insertion mode appropriately. What does that mean? Okay. Some big algorithm once again. So let last be false. Yes, sir. Let node be the last node. Element. Oh wait, we call it node. Dot. Last node in the stack is the current node. Or wait, what do they mean the last node and the first node? The topmost and the bottommost, yes, but who's the last and the first? That's not cool, dude. Why are you calling it first and last when you've only ever talked about it as topmost and bottommost? Who's the top and who's the bottom, and who's the first and who's the last? That's a bad spec. Bad spec. This is the first time I actually feel like this is a little bit too ambiguous. Anyway, and that really says something. I mean, this thing is extremely good, right? The spec is amazing. Like, you can actually translate it to code quite readily, like I'm doing. But this part just bothers me. Maybe it's I'm getting tired. But let's see. If node is the first node, then set last to true. And something parsing. Okay, so what happens if we just, or no, we're supposed to do something here. I think last node, I'm just going to assume that it's the last most recently inserted, which will be the current node. Okay, so loop if node is the first node in the stack of open elements, then set last to true. Whatever, dude. True. So let's add an API here, I guess. Element first. First and last. I mean, you can have it. I hope that it's accurate. Oops, HTML document parser. Alright, so far so good. Last true if m parsing fragment to do. Okay. If node tag name select to do. And then if node tag name is one of to-da or to-uch. Insertion mode is in cell. Alright. If that's what you say, dude. If it's a TR, go back to in row. If it's a T body, T head or T foot. Then go back to in table body. Okay, so there are a whole bunch of these, right? So let's just quickly caption, then we go into in caption. I just want to get to the one that says table because it's the one that we need, right? So now we have call group. And then comes table. Go back to in table. And then, I mean, there are not so many more rules actually. If it says template, then to do. And then we have body. Frame set. Switch to insertion mode to in frame set and return. And then we should have some fragment thing here, so I'll just put it to do. And then if it's an HTML, we'll have a to do for that as well. And then if last, switch the insertion mode to in body and return. Otherwise, node should be the node before node in the stack of open elements. Okay, so we're just supposed to iterate backwards. Wait. Oh yeah, right. So we iterate to the until we reach the very first one. Stack of open elements, entries, elements, size -1, I, minus I, and then we can do it this way, that we just say stack of open elements, elements at I. So we iterate backwards, and then when we exit this function, so if last is true, so I guess if we exit the loop, then we should switch the insertion mode to inbody. So if we ever exit this loop, exit the loop, then we should do some parsing gunk and reset to inbody. Got it. Yeah, I think that's okay. Well, we kind of loaded. Oh, the images are not here. And it's very crashy. Crashed the whole system. What on earth? Okay, well, crashing when I'm mouse overing the document, that's an engine problem. That's not something we have to deal with. Just with this thing, I think that's a separate problem. But we were at least able to parse google.com. So I'm going to consider that a success. We do have this hack that just skips over character references. I suppose that's probably why images don't load. Although it might not be, actually. Let me test something real quick. If we load with... Can we go to the Serenity website? We can't. Okay, well that one we can definitely fix. Initial start tag HTML, and we choke on that. Wait, what? Serenity, the Serenity website needs to work for sure. At the very least, it needs to parse. So we have initial, and we get an HTML. I guess we don't have a doc type. That's the problem, right? So let's take a quick look at it. Look at that. Who made this website? He didn't even put a doc type. What an absolute madman. So this is a parse error, and we should set it to quirks mode. I guess we can do that. So here we'll just say document set quirks mode true. Doesn't really exist yet, but we can still set it. This is a parse error. Set quirks mode, and insertion mode is before HTML, and process using the rules for insertion mode before HTML. Then let's just add something quirks mode. I thought I added something for that. Oh, I guess I didn't. Well, now we're adding a quirks mode to our document class. Maybe here at the very end. Bool m quirks mode. In quirks mode, set quirks mode. Well, isn't that nice? Then we can start implementing quirks mode later on. This project is just... It is my favorite project ever, I have to say. I think we're coming to a close here for the day. So yeah, this is definitely my favorite project ever, and super interesting, super fun. A lot of great people A lot of great people who help out on it, and I get to share it with everybody. So the experience is just absolutely amazing. Why did we crash now? In body, in tag A. We can't deal with that either. 584. If there's no such element. Oh, I see. So I have a mismatched tag on there as well. Is that really true? What are we doing? Buggy. We have the buggy image, and then we have an end tag for A. A image source. Oh, wait, I've opened this thing. But this thing is a self-closing element. So this is supposed to succeed for some other reason, right? In body. Let's see, so what happened when we inserted the img? Start tag. Is this in body? I feel like this is in body. It's gigantic. Yes, this was in body. Okay, so we have some special conditions for img. We don't respect that, so we can fix that probably. Handle in body. All right, my friend. If token is start tag and token tag name is one of all of these friendly friends, and then we want to reconstruct the active formatting elements, insert an HTML element for the token, immediately pop the current node off of the stack of open elements. You got it, dude. Acknowledge the token's self-closing flag if set. Boom. Set the frame set OK to not OK, and return. Okay, I think maybe this will do it. Maybe that was why Google didn't get images, actually. Maybe my original theory was all wrong. We have our website. Awesome. What about Google? We got an image. Okay. That's so good. I'm missing the inputs. But damn, dude, like this is awesome progress. So we're just gonna cut it off here for today. I'm gonna do some commits. Liblab add quirks, quirks mode flag to document. This doesn't do anything yet, but it will sooner or later. All right, cool. And then, let's see, so we're not going to add the character reference hack. I'm going to have to actually implement that properly. But, let's see, this one I don't want. This one, a bunch of new modes. This is handling the initial, that one. We can do this one separately, because that was a fix for serenityos.org. So, oh wait, I have to actually go through this before I can. No. I thought I would be able to commit like there. Handle documents, parse documents without doc type gracefully. It seems like someone forgot to put a doc type on serenityos.org. Yes. Wait, hold on. Let me say something more about that. No matter. Now we can handle it in the new parser. Great. All right, not that. What is this? This is the Oh right, this is the fix for the children changed issue. So let's do that one separately. Does this? Oh, it doesn't. Damn it! I wish I could just. I just want to add like that one hunk and then quit out of that thing. Maybe I can. So not this hunk, not this hunk. Yes, this hunk. Can I exit? No, that's not what I want to do. Wait, did that make me add that hunk? Did I stage it? I have no idea what I'm doing. Yes, it did make me stage it. Wait. Oh. Git add -p is awesome, but also confusing. So not that, yes, that, no, no. Yes, no, 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 no. What? Handle inline style sheets a bit better in the new parser. While we're still supporting both the old and the new parser, we have to deal with their the way they load inline style sheets and scripts a bit differently. The old parser loads all the text content up front and then notifies the containing element. The new parser creates the containing element up front and appends text inside it afterwards. For now, we simply do an empty children changed notification when first inserting a text node side element. This at least prevents the CSS parser from choking on a single character style sheet. Okay. And then I had some more individual changes here that I liked. This is in body, so that's handling images quite nicely. Web handle various self-closing tags in the in body during in body insertion. Now parse self-closing img tags correctly. Cool. I guess we should say, yeah, well, yeah, that's fine. And then, no, this is the table stuff. No. No, but this is implementing reset the insertion mode appropriately. So we'll do that one. And this one required the... Wait, did this need anything from the outside? It didn't. Implement. Flesh out. We reset the insertion mode appropriately a bit. Yep. I mean, we can say some, yeah, flesh it out. Flesh out the algorithm. Was that even the name of it? Reset the insertion mode appropriately. Yes. And now we just have a whole bunch of table stuff remaining. So not you, yes you, yes you, yes you, you, not you. Implement, start, implement more table support in the new HTML parser. This is enough to parse the Google front page. Note, I did have to hack the tokenizer while parsing Google in order to avoid named character references screwing everything up. We'll fix that too soon enough. All right, so since this is a hack, let's clear our conscience and see that Serenity OS still works. So very noisy parser once again. Website looking good. Bug bounty program looking good. What about this one? Can we load it? Yes, it works. Really cool. Okay, so wait, I have one more page here that I made. Ah, it loads. Yeah. And oh yeah, it's a great way to advertise my GitHub sponsors thingy as well, of course. So this is going to be the end of today's video. So if you made it this far, then I thank you for hanging out and for sticking it out with me through yet another deep dive into HTML parsing and implementation. Hopefully people are starting to see that it is possible to build browsers, and this is how you do it. You just follow the specs and do what Dr. HTML says. And eventually, with time and effort, you will have a browser. So this is really, really fun, I think. I hope that it's interesting for people. Thank you very much for hanging out and for watching this. I think it's really, I'm so happy that I can share it with people. So I guess I'll see you next time. And yeah, check me out on GitHub sponsors and Patreon and all those things. There are links in the description. Catch you later.